Welcome back to the channel. In this lab, we're going to be focusing on Hack the Box's base. It's going to be primarily focusing on PHP. Let's go over the introduction here before we begin. PHP is one of the most popular backend languages in the world. It's flexible, cross-platform compatible, cost-efficient, and easy to learn. Services like Facebook, Wikipedia, Tumblr, Hack the Box, and Yahoo are built with PHP, not to mention WordPress and any other content management system. However, PHP can often be misconfigured, which then leaves huge vulnerability holes in the system which cyber criminals can exploit. Ethical hackers and penetration testers need to know how PHP works, along with many varieties of misconfiguration that they discover. The base machine teaches us how useful it is to analyze code and how one slight mistake can lead to a fatal vulnerability. As always, we'll begin with some basic enumeration of the website, and we also are provided with a website we can go to, the IP 10.129.6.3.180/login with another index login PHP. That is the first site we'll take a look at. Right away, we're able to see that there's an extra login directory where login.php is stored. So we're going to try to access that. And that's what we do here with the index of login. Simultaneously, we'll run an nmap scan to check any open ports and services running on these machines. Open the terminal as root or CD to root, whatever you need to do. We're also able to see that the login folder seems to be configured as listable, and we can see the PHP files that are responsible for the login task. And there's also a swap file, which is or SWP file, which is a swap file. Swap files store changes that are made to the buffer. If a Vim or your computer crashes, the swap files allow you to recover those changes. Swap files also provide a way to avoid multiple instances of an editor like Vim from editing the same file. More information can be found in the notes. And it says the swap file was probably created due to the crash of the Vim application while the developer was editing the file. The file ended up being unnoticed and left in the web application file, which we can actually see here. Login.php.swap, and it's listable in the directory. Web server is set to handle requests to PHP files while running the PHP code in the file, but because the extension of the swap file isn't .php, the web server returns the raw code as text, which we're going to see right now when we open this login.swap. We can cat the contents, and here's the raw code in the terminal. Let us click on this file and download it for further analysis. Navigate to the folder where the file is downloaded and read it to see if any parts of the code from login.php were saved. Typically, the most straightforward way to recover a Vim swap file is with vim-r followed by the file name. But sometimes these files can be particular and won't recover. As a swap file is a temporary file, it contains a lot of non-human readable content. Thus, we will use the strings utility to read the swap file because strings will only display human readable text. Let's go ahead and do that. All right, we're going to use the strings command. You can also read through this data and look for any usernames, passwords, but we're not really likely to find anything. You can see some if statements for password and post, but typing in strings.login.php and the swap. We've made it possible to view the strings and human readable characters with any file. The main purpose of using a strings command is to work with what type you're looking at, but you can also use it to extract text. Output from the strings command is as follows. Vim 8.0, root base, and then there's a path of var, www, HTML, login through login PHP. And then we have the diagram of the code below. This would be the HTML code. At the top, scrolling up, we do see the Vim 8.0. We do see root. We do see the name of the box base and the path. Now, if you were to go through this code, some of it's going to be jumbled. Some of it's out of order as well. Still, there's enough we can figure out what the code's trying to do. And specifically, the block PHP code that contains the login appears to be upside down. In the interest of time, I'm not going to really go and find that. To make it look normal, we can place the output of the strings command inside a new file and read it to the tack utility, which reads files similar to cat, but instead does it so in a backwards manner. So what we're going to do is strings login.php swap. We'll save it to a file, and then we'll tack that file just to kind of clean up this output here. We'll type in strings login.php.swap. Save the file, text, then tack the file. All right, we've cleaned up the code a bit. Session start, if empty, post username. All right, so let's go ahead and find the field we're looking for. I believe it was at the top. I just said it. Yep, so we're looking at this first little block of code. If empty, if username is empty and password is empty, require configure.php. Let's see, if username is equal to 0, password is equal to 0. All right, so basically the problem with this code here is the file is checking the username and password combination that the user submits against the variables that are stored in the config file, which is potentially communicating with the database to see if they match. Here's the issue. If the string CMP username post here, not there, here with the equals, and the password, which is equal to 0, just as previously mentioned, the strcmp function is used for string comparison and returns a 0. When two input values like that are identical, it's insecure, and the authentication process can potentially be bypassed without having a valid username and password. This is due to the fact that string CMP is given an empty array to compare against the stored password. It's going to return null. In PHP, the equals operator only checks the value of a variable equally, and the value of null is equal to 0. The correct way to write this would be to actually include another equals operator, which would check both types, value and type. And this is prominently known as type juggling bugs. Scrolling down in the notes, we can actually see some more information about the bug. In the above code, we see that if the comparison succeeds and returns 0, the login is successful. If we convert those variables into empty arrays, username, array, and password, empty array, the comparison will return null, and null is equal to 0. And that's going to return true, causing the login to be successful. So here you can see if string CMP username post. And where is the actual empty array added? It's not added here, but we're going to add it in a minute. In order to exploit this vulnerability, we'll need to intercept the login request in Burp Suite. To do so, fire up Burp Suite and configure the browser to use as proxy, either with Foxy Proxy plugin or the browser configuration page. Then we'll send a login request with a random set of credentials and catch the request in Burp. All right, let's do that now. You can navigate back to the web page here, the normal login.php, and let's launch Burp. Here's Burp Suite. We'll type in whatever admin password that you decide. We'll grab the traffic. And hopefully we're going to get a login request similar to here, similar to the diagram where you're able to read plain text username and password, which is here at the bottom. Sometimes Burp Suite is a little bit finicky. You have to turn the intercept on and off. Sometimes it's better to use the actual browser within Burp Suite than it is to try to run it in your own browser through the extension. So it just really depends what you're able to do, what it's allowing you to do. Here we catch the credentials that we've typed in, admin and admin again for the password. We're going to change the post data as follows to bypass the login. We're going to add the array now. So we'll do the username array. Empty array is equal to admin, and password is equal to the empty array of password. Send it to the repeater so that we can actually change and send the request back to the web page. This will convert the variables to arrays, and after forwarding the request, the string CMP returns true and the login is successful. Once logged in, we'll upload a final file. That's probably going to help us get some sort of shell. Here we've input the empty arrays into admin and password and sent the payload or the request back to the web server. And here we can see that we've been able to successfully log into the admin file of uploads. We're able to select an upload. So now it's time to get a payload onto the website and then get a reverse shell and get some more information. Scrolling down in the notes, we can see foothold. Since the web page can execute PHP code, we can try uploading a PHP file to check if the PHP file uploads are allowed or not. And we can also check for PHP code execution. We'll create a PHP file with PHP info function, which outputs the configurational information of the PHP installation. We went over that in previous labs. Basically, it's that purple PHP page. It shows a bunch of information about the web server. We're going to use this this little function here, or echo PHP info, and then we'll save it as test.php. We'll then upload it. On the right side, open up your terminal. And we've actually done sudo nano This is going to open up a terminal. We can save the PHP code here, as well as save the output of the file to test.php. You will need root privileges to do this, hence sudo. Sometimes I can't type, but that's okay. Here we can see we've saved a bunch of other files. I think this is actually like on root, since we use sudo nano. Problem is the file got saved, so we're gonna have to move it. No problem. I don't really like searching through this open files here on Linux. It's much better to learn how to use the terminal and to use it frequently. You'd be surprised how many senior sysadmins and other senior individuals I've encountered that haven't used Linux in about a decade. We'll just leave that information there. You do what you want with that. I believe we saved it as testsys.php. We've successfully moved the file. And we will upload it from our desktop now. We'll get a little green arrow. It says that we've uploaded successfully. My big head is in the way. Next, we need to figure out where the uploaded files are stored. To do that, we will use GoBuster to do a directory brute force. It's perfect. Could search all day, or we could just use GoBuster, and we'll do that now. Open up another terminal. You may have to update or download GoBuster. We'll use the command GoBuster dir for directory, followed by URL. We'll implement the URL or the IP 10.129.63.180. We'll need to choose a word list. Looks like we're provided with a word list from the user. Share word list dirb big.txt is the word list we're going to be using here. See, here we're installing GoBuster. This could take a little bit of time. For us, it's fairly quick. And we'll begin running it. This also could take quite some time. Here we see htaccess, htpassword, and we find very quickly a uploaded directory. It's a very good chance that the file we uploaded is in that directory. In the interest of time, we'll stop the scan. You can also see assets, directory, forms, login, server status. Let's go check out this uploaded directory. You can right-click the path here in the terminal. It's going to bring here index of uploaded, and we can see we've successfully uploaded our testsystem.php file. We can click on it, and it's going to bring us that nice PHP information in a minute here. We brought up some PHP version 7.2.24, Ubuntu. We got build date, server API. We got directory support, APIs, extensions, zone information, registry information, Apache version, etc. Let us now create a PHP web shell which uses the system function and the CMD URL parameter to execute system commands. Place the following code into the file webshell.php. So it's going to be our web shell here. PHP echo system request command CMD. We're making use of the request method to fetch the CMD parameter because it works for fetching both URL parameters in GET requests and HTTP request body parameters in case of post requests. We'll use post request later in the walkthrough, thus using the $ request method is the most effective way to fetch CMD parameters in this context. Just like before, sudo nano in terminal, we'll create a new file here and we'll implement this PHP code. Save it as webshell.php. Again, this system's acting kind of funny, so we're going to move the file to desktop again. Spare you the headache here. We'll use mv for the move command, followed by the file name, followed by where we're moving it. Upload webshell.php. We have our webshell.php here. Let's check out the notes. We're making use of the request to fetch the CMD parameter because it works for fetching both URL parameters. We already went over this. Cat the webshell.php, and we should get this echo system request back. Let's see if that works. Basically, what this is checking to see is if the server is responding to our request or not, in shorter terms. Scrolling down a little bit after the file has been uploaded, click on it in the browser and it will show a blank page. However, if we add system command and CMD URL parameter, the PHP backend will execute its value. So we're going to have to, an example is question CMD is equal to ID. And so we need to set the ID. Let's go ahead and go over to the web page here. We type in the uploaded webshell.php or click on it, and like the lab mentioned, we get a blank page. We'll modify this URL. We'll add the CMD is equal to ID parameter here at the end. And upon hitting enter, we do get results back. The above URL returns with the output of the ID command, letting us know that Apache is running in the context of the user's www data. Let's intercept this request in Burp Suite again and send it to the repeater tab by pressing Control-R. Okay. So let's go ahead and capture this info back in Burp Suite, and we'll go ahead and do that. Launch Burp Suite again. Configure your intercept. Make sure intercept is on. Catch the requests. You can go to repeater. Now that we know we can execute code on the remote system, let's attempt to get a reverse shell. The current request is an HTTP request. Here we see that. And we can attempt to use it to send a command that will grant us a reverse shell in the system. However, it's likely that one might encounter errors due to the presence of special characters in the URL, even after encoding them. Instead, let us convert this GET request, here we can see the GET request, to a post request and send the reverse shell command as an HTTP post parameter. Right-click, change request method. You can see it changed it from get to post. On the repeater tab, we could alter the request and set the following reverse payloads as a value for CMD parameter. So we're going to set the value of the reverse payload bin bash, call bash, dev TCP, our IP address, listening port, and zeros and equal 1. This reverse shell payload will make the remote host connection back to us when the interactive bash shell on the specified port we're listening on. All right, we'll implement the bin bash. Command shell right here in the CMD and burp suite. In order to execute our payload, we'll have to first URL encode it. So we'll go ahead and type in the IP of our listener. Of course, we'll have to set up a listener. Here's a brief description about why we're encoding the URL. It's important to URL encode the payload, or else the server will not interpret the command correctly. For example, in the post body, the AND character is used to signal the start of the new parameter, but we have two AND characters in our string symbol that are both part of the CMD parameter. By encoding them, this tells the server to treat this entire string as part of the command. Right click it, and we're going to encode this. Now is also a good time to open up a netcat listener. You can do sudo nc-lvnp 443 is the port. Now we're listening on port 443. Let's go ahead and encode this payload and send it, and we should receive a reverse shell. Upon successfully uploading the payload, we receive a reverse shell. Lateral movement. As we already know, the Apache server is running on the www data as we already know, the Apache server is running as the www data use, and the shell we received is also running in context of the user. www data is a default user on systems where web servers are installed and usually has minimal privileges. Let's enumerate the system, see if we can find any interesting information that might allow us to escalate our privileges. We'll first check the configuration file in the login folder that we found earlier. These files often include credentials that can be used to communicate with SQL or other types of data storage servers. So we'll go to config.php, cat the contents of it, and it should give us the username and password after we do that. Cat var www html login config.php. Okay, no file or directory. Third time is a charm. Let's try again. All right, here we have the username and password. Admin for username. Password is, this is a good password. The config PHP file reveals a set of credentials. System administrators often reuse passwords between web systems and accounts so they do not forget them. Let us enumerate further to see if this password is valid for any system user. To do that, we'll first list the files in the home directory to quickly identify users on the system. We'll check what users are there, and then we'll try to log in. They provide the commands ls home. And they tell us we're looking for a John, a folder named John. We'll type this in, ls-all. All right, ls-home. We see John. There's only one folder here. We'll switch users to John. Immediately, it's going to ask us to log in. We'll try the information that we found. This is a good password. And looks like we logged in as John at base. Using ls reveals test.php, webshell.php, testsystem.php. It's telling us to check the home John user.txt. So basically there's no information in here. Let's try to SSH into this base server. And see if there's files on there of interest. Upon logging in, hitting ls, we get user.txt, cat that, and we have received a flag. Although we've received a flag, there is another flag that's located under root, so we're going to have to use some privilege escalation techniques here to move forward. We now need to escalate our privileges to that of the root user who has the highest privileges in the system. Instead of running a system enumeration tool like linps, let us first perform some basic manual enumeration. Upon checking sudo l command output, which lists sudo privileges that our user has assigned, we see that the user John can run and find command as root. Sudo l, type in password for John. User John may run the following commands on base: root, user bin find. Cool. It's rarely a good idea to allow a system user to run binary with elevated privileges, as the default binaries on Linux often contain parameters that can be used to run system commands. Now it's going to provide us here. Here we're going to be taking a look at GTFO bins. We've done some Linux privilege escalation in the past, and we're going to be using the same techniques here in this lab. So if you check the terminal here, you can say user bin find. What we're going to do is we'll go to GTFO bin, and we're actually going to search for the find binary. Once you've navigated to GTFO bins, you have a bunch of options for functions and binaries. we're going to use Control F to save some time, and we're just going to search for find. We have a few options here: shell, SUID, or sudo. We'll use sudo since we have root. If the binary is allowed to run as a super user by sudo, it does not drop elevated privileges and may be used to access the file system, escalate, or maintain privilege access. So we'll use the command sudo find.exez bin shell, and then we'll quit. According to GTFO bins, we need to run the following command in order to escalate our privileges. Let's go ahead and do this. Running the sudo find command is going to execute the bin shell, and we are actually now root in the folder. If we ls, we get user.txt. ls all, we see some more files here. We have profile, local, cache, bash history, user.txt. We can use the who am I and ID to check who we are, and it says root. At this point, we'll cd to the root directory, use ls. We will cat the root.txt file, and that will give us the root flag for this lab. We can go back to the questions here and begin to answer those. Which two TCP ports are open on the remote host, 22 and 80? I guess that's wrong, whatever. Let's fix this. Which two TCP ports are open on the remote host, 22 and 80? Task 2, what is the relative path on the web server for the login page? That's going to be the login.php. Which PHP function is being used in the backend code to compare the user submitted username and password to the valid username and password? That's string CMP. In which directory are the upload files stored? This would be the uploaded directory. Task 7, which user exists on the remote host with the home directory? John. Task 8, what is the password for the user present on the system? This is a good password. 9, what is the full path to the command that the user John can run as user root on the remote host? So this is the command that we use in the GTFO bin. This will be the user bin find. What action can find the command? What action can the find command use to execute commands? That would be exec. Then it's just asking us to submit the flags, the user root flag, and the regular flag for John. We submit the flags, and we've successfully pwned base. Thank you for watching. If you liked the video, like, comment, subscribe.